Here I'm going to tell you everything you need to know about the essential right triangles. Essential right triangles isn't really an official term, but I'm calling them that because they show up all the time on standardized tests and in introductory geometry classes. The basic idea here is that once you memorize these triangles, you'll be able to avoid using the Pythagorean theorem and thus save some time on geometry problems. Pythagoras tells us that for a right triangle like this, a squared plus b squared equals c squared. And this is great, except that the calculations can be a little time-consuming. So if you know these triangles by heart, it's better to use this rule. It tells us that if two sides of some unknown triangle match one of these models, so does the third side. So, for example, if you saw this, you would notice the 3 and the 5 match the model, so this unknown side has to be 4, just like in the model. And this also works for multiples of these side lengths. So if you saw this, you would notice 6 and 10 are double 3 and 5, so this unknown length has to be double 4, which is 8. You can use this rule with any of the triangles on this page as long as you know their side lengths. For the yellow ones, it also makes sense to know the angles. This one is a 45, 45, 90, and this one is a 30, 60, 90. And if you know these angles, you can make use of a second rule. This one tells us that if a new triangle has all its angles plus one side matching one of these models, then the other two sides will also match. So, for example, if you saw this, you would notice these angles are the same as in this model, the hypotenuse is also the same, so the other two sides also match, meaning this is 1 and this is root 3. And this also works with multiples of these side lengths. So if this were labeled 10, you would notice that's just the original times 10. So this one becomes 10 root 3, and this becomes 20. By the way, this second rule applies to all right triangles, not just the yellow ones. But in practice, nobody bothers to learn the angles on the pink triangles because they have infinitely many non-repeating decimal places and are therefore impossible to memorize. Speaking of memorizing things, it's a good idea to print out or screenshot this page for your personal use. Although, if you have a really good memory, you might make room for a couple more triangles. This one, 7, 24, 25, and this one, 9, 40, 41. These sometimes show up on standardized tests, but less often than the ones above. Now, you might wonder, is this it, or are there more pink triangles out there? Well, what I've been calling a pink triangle is just a right triangle with integer sides. And it turns out that there are infinitely many such triangles. Here's a chart that lays them out systematically. The ones we've already talked about, such as 3, 4, 5, are clustered here at the bottom left. As you look away from this origin, you see triangles with longer and longer sides. If I were to zoom out, you would see even more of these. And the point is, I could zoom out forever and we'd never run out of pink triangles. If you'd like to find out more about this, look up Pythagorean triples. A Pythagorean triple is just a set of 3 numbers that gives you the side lengths of one of these triangles. For example, 3, 4, 5, or 280, 351, 449. Anyway, nobody's going to ask you to memorize any of these big triangles out here. You'll be perfectly fine with this list or even with the shorter one that we started out with. And now it's time for me to say thanks for watching this video from Chiron Prep. I hope you'll give it a like and check out some of our other content.